Example 2. Evaluating an integral as a limit of Riemann sums. Part A. You want to evaluate the Riemann sum for f of x, which is equal to x cubed minus 6x, taking the sample points to be right endpoints, and a is equal to 0, and b is equal to 3, and n is equal to 6. Okay, first and foremost, let's take a look at the graph. So here is the graph. Okay, we can see it's in blue. Okay, and what we want to do is we're going from 0 to 3. So therefore, the graph is going to go from 0 to 3. And then let's take a look at the right endpoints. So if we take a look at the right endpoints, that means that we're going to create these right rectangles here. And again, that is below the x-axis. Okay, and so therefore there are our rectangles below that curve. Okay, and then when we take a look at it being above here, so there are our rectangles where it's above the x-axis. Okay, so recall that this is going to be positive here, and therefore it's going to be negative in those. Okay, so now let's go ahead and figure out what is our width. So we need to find out what our width is, and recall that the width, which is delta x of the rectangle, is going to be the value of b minus a over n. Well, we know that b is 3, we know that a is 0, and we know that n is 6. So we're going to get 3 over 6, which is equal to 1/2. Okay? And now also, what do we know? We know that the initial point, x subscript 0, is going to equal the value of a. So we know that a is going to equal 0, because that's what's given. And then recall that the formula, okay, for x subscript I, which is going to equal x subscript 0 plus I times the width. So now we want to find x subscript 1. So that means what we're going to do is we're going to take 0, which is x subscript 0, plus we're going to take that 1 and then multiply it by the delta x. So 0 plus 1/2 is going to give us 1/2. Okay, let's find x subscript 2. Again, we're going to take x subscript 0, which is 0, plus now the I is going to be 2. So 2 times 1/2 is going to give us 1. Okay, x subscript 3. We're going to take 0 plus. We're going to take 3 and then multiply that by 1/2, which gives us 3 over 2. Okay, and then x subscript 4, which is going to equal 0, plus 4 times 1/2 is going to give us 2. Okay, and then x subscript 5 is going to equal 0 plus 5 times 1/2, which is equal to 5 over 2. And then x subscript 6 is going to be 0 plus 6 times 1/2. And so that 6 times 1/2 is going to give us 3. Okay? And recall that we started with a, which is equal to 0. And then we end at when b is equal to 3. So that's why we're ending here, because that represents our value for b. Okay? All right, so now what we want to do in step number 3, okay, is to be able to then evaluate the summation of this. And so the summation is where I is equal to 1, and it's going to n, which is equal to 6, of our function, which is x subscript I cubed minus 6 times x subscript I delta x. Okay, so what does that equal? Well, that's going to equal the following. Okay, well, that's going to equal, we're going to find the sum of that. So the sum is going to be, and I'm going to bring that down a little further to make just a little bit more room for us, okay, as we work through this problem here. Okay, so what do we know? We know that the first point that we have here is 1/2 for x1 because we're taking the right endpoints. So this is x1, this is x2, this is x3, x4, x5, and then x6. And we know what those numbers are from looking over here. Okay, now let's keep in mind that what we're doing here is we're using the right endpoints. So technically what we're looking for is R6, since n is equal to 6. Okay, and so what does this represent? That means that if we want to solve here, this is going to be f of x1, which is the right x point, okay, times delta x, plus f of 1 times delta x, plus f of 3/2 times delta x, plus f of 2 times delta x, plus f of 5/2 times delta x, and then plus f of 3 times delta x. Okay, so let's go ahead and then plug that information in. So that means that we're going to take this value of x cubed. So that means we're going to take 1/2 and then cube that minus, so we take 1/2 cubed and then we're going to minus 6 times 1/2. And then plus, we take 1 and then we cube that minus 6 times 1, plus we have 3/2 cubed minus 6 times 3/2, and then plus we have 2 cubed minus 6 times 2, plus 5/2 cubed minus 6 times 5/2, and then plus 3 cubed minus 6 times 3. Okay, so when we add those all together, then we're going to get the result, multiply and add those together, negative 3.9375 as the area. So there is the area using the right endpoints. And let's just take a look at this graph, okay? So I want you to notice that f is not a positive function, and so the Riemann sum does not represent a sum of areas of rectangles, but it does represent the sum of the areas of the blue rectangles above the x-axis minus the sum of the areas of the gold rectangles, which is below the x-axis in this figure above.